Alright, let's have a look. Alright, it seems we are live. Let's check what our audio sounds like. My audio. Turn the volume up. Let's see if I can hear myself here. Alrighty, so what we are doing here today is it is a Sunday evening, so how you all doing? Been a good week? What have you been up to? I've been making a whole bunch of these little boards. So what it is it replaces a chip that goes in here, an analog devices chip, and it's a little daughter board that looks like this. Okay, and I've made them. This is a strain gauge amplifier, by the way, for load cells. Got it connected up. Here's our strain from the strain amp simulation signal. Here you can see it. It's called a cross. So you've got a potential divider. You've got your 10 volts out. It goes across the pot. It goes across two resistors, a potential divider. Then coming out of the potential divider, you've got two resistors, so it's called a cross. So across the middle point, across, I am measuring, so the wiper of the pot goes to the one side of the cross, so it pulls it positive or negative with respect to the midpoint, and it generates the millivolt signal for us. So if I turn it on here, we should be able to see our millivolt signal over there. Let's select millivolts. So there we go, we got millivolts. Alright. And here I'm reading the voltage out, which is a plus minus 10 volt signal from the strain amp. Now what these are used for is an automotive application for vehicle brake testing, for roadworthiness certification and licensing. So in my spare time I'll build these to help somebody out. So that's what we're doing here. This is what I was largely involved with in my earlier career. So what it's supposed to do is at a full minus 50 millivolts give me 10 volts. So what I'm going to do, let's just try and fix this polarity. Let's swap these around. Like so. Okay, you can still see nicely on the screen there, and you can see me on that cam over there, which I upgraded today. So turning it fully clockwise gives me 50 millivolts. I should have about 10 volts, so we're going to have to look at this one. There's something not right with that, because when I go to 0 millivolts, 0 volts, on the output like that. I should have 0 volts here. So something not right here, this one. That's minus 49 millivolts. Like so. Alright. So this is a known to be working unit. Got on there now. So what's supposed to happen when I plug it in is I'm supposed to get close to 0 volts. Like that. Okay, so that one's strange. Now I've got 10 of these to test. So let's grab another one. Put it in. See how it does. It is doing the same. That's interesting. This one is working correctly. Alright. So go all the way up to 50 millivolts, 10 volts. And back down to minus 50 millivolts, minus 10 volts. So that one's working correctly. Right. So that's a good one. So I'll set that to the right there, over here. Let's get another one. Let's go through all of them, find the ones that are working correctly, and then we'll look at what we've done wrong with the assembly of those other ones. I got some new flux in Kingbo. I was using this for the assembly. So what we may have to look at is whether we were soldering these things correctly. Because I don't think I have a problem with the resistor values. That one's also off. So I might have a soldering issue. That one's working correctly. There we go, up to 50 millivolts, down to 48 millivolts. Yeah, that's working correctly. Trust me to have a whole bunch of these that don't work on a live stream. But that's how life goes. So we see that this one's correct. Yeah. Let's keep going. We've only got 10 of them to do. Nope, there's a problem. So, got a whole bunch of these things to fix, it seems. Oh, 1 volt. No, that should be closer to 0 volts. I'm not happy with that. Oh no, I put it in the wrong place. Doesn't belong there. Now mix them up. Okay, put it with the bad ones. Keep going. So it's going to be interesting to see what went wrong with my process. No, that's also not right. So look, what I'm going to do is turn some more lights on so that we can see what we're doing, yeah? Why is that one not working? Because of a bad electrical connection. Let's have a look. The 2K is where it should be. And the 10K is where they should be. Check all the pins on the op amps, because not soldering them would do it as well. I do not see it. This is the joys of working with electronics. Unfortunately, I can't show the circuit diagram for this here because these internal workings are kind of a secret to us. So what I'll do is I hand solder these, and that's it. I don't use hot air for what we're doing here. It is easier to just hand solder. Turn the iron on. I think I can see what the problem is with this one. See, what has happened here is I've tried a new flux, and I changed something in my process, and of course things happen because of that. So what I'm going to do is scoot this stuff up a little bit. I can move this camera up a little bit, like so. You need some solder. I just said that resistor at the end could be a problem, and that middle one. So let's reflow them over there. See how it goes. Need my solder brush. And just flow that one again. Same for its neighbour. There is still flux on the board. See how this goes. I should flow that next one as well. Let's see what happens after this, and then we'll know what direction we're going in with fixing whatever problem we have with our manufacturing process. God, I smell this flux. My fan's over there. I've put it out the way because we're not doing a lot of soldering. We're not going to worry about it right now. So he said that's not a working board. So let's take it out. Volts, no, that ain't right. Oh, I know what I've done wrong here. Let's reflow. The ones on the other side. Let's see what's happened. Reflow that one as well. Let's see what has happened here. Turn the meter back on. No, that one definitely not happy. I'm just going to try something. Let's put this out the way. pumps camera. Just going to clean off the flux and have a look. See if we can see the problem. Get it cleaned up with some Kleenexes. There's a very slight chance that I might have a problem with this flux interfering with this op-amp circuit. So let's eliminate that as a problem. Or a potential cause. At least this flux cleans off very easily. That wipe with alcohol cleaned it right up. Let's plug her in. No, it does not want to work. Let's check my test check. Yep, that's right. So what's going on here? Everything soldered. Oh, it should be. Very interesting. what I'm going to do, see, maybe we still have a little bit of it in there, enough to be a problem. So let's clean it up like that. Gonna have a fine mess to clean up on my desk later, but that's okay. First we're trying to find out what's gone wrong here with this process, because the one thing I changed is the flux that I use, and now I have a problem. So what have I done wrong? Need be that should be absolutely clean now. So another look at the loop. See what it looks like. Seem to have got the flux out most places. Oh, that one's settling down. Okay. Go the other way. Minus 50. Go to plus 50. Go down to 0 volts. Yep. That one started working. Okay. So I think we've identified the cause of our problem. What happened is we changed our flux to this stuff, which is very nice to solder with, but it means that cleaning afterwards is important. Okay, that's good news. So what I'm going to do, let's grab another one. Let me clean it. What I'm going to do, in fact, is take the other ones and put them upside down in the jar or tub, like so. And we're going to pour some ethanol all over them. Like that. Let them marinate in there with it, like so. Then we're going to take our single specimen here, scrub it, and see if it comes to life. Because previously I was using a different flux. I was using this Digmet solder media, which causes less of a problem if you don't remove it, but it doesn't solder as well, and it is an absolute bear to remove. It involves soaking and scrubbing with alcohol. Oh man, it's not fun at all working with that stuff. Because we're dealing with such low currents here on this amplifier, it's so much more important to have it 100% clean. Let's clean our toothbrush. Oh, it's now become a PC board cleaning brush. Not going to be a toothbrush again. Not intentionally anyway. Right. Now the Kingbo is certainly cleaning off very easily, beautifully. There's no sweat to get it off. With some IPA. So let's take that one out. Set that aside. Let's just inspect it first. Yep, she's clean. So let's test it. See how this worked out. that one's holding steady, the 20 volts. And it's not changing. What I'm doing is I'm just pushing down on the components. See if that has any effect. But it's not. Let's see what's going on here. I suppose that one could be a problem. I could reflow that. That resistor on the end there. It looks as though it's not attached on the one side. So what we're going to do, get some of this stuff. Take a Q-tip, dip it in there. Put some on our board and reflow it. Like so. Let's see what is going on here now. It's settling now. But I think we still have a problem. Somewhere one of my joints are not right. Nope. When your eyes on, turn on a bit more light. So I can see what I'm doing. I'll turn it off again. I just need a bit more light over here. Now while we're at it, we could add a bit of mood lighting. Some blue light. Let's just reflow them some more. I might also have a bit of a temperature that's too low on the irony. And inject that up just a little bit. This wire that I'm soldering with is 0.46 millimeter. It's a nice fine wire. Let's see how that has worked out. Don't swamp out this meter so badly for you guys. Okay, it's all sitting at 5.5 volts. Let's keep going. Let's do the other side. Flux it all up good. Q-tip. See how we're doing with this. Whenever one makes a change to a process, it introduces problems. Need a bit more flux over here. that's all of the resistors reflowed. Boom. Can see that voltage coming down as the board cools down. Let's turn it all the way up to 50 millivolts. Turn it back down. Probably not the most interesting stuff to watch, me testing boards. But this is how it goes. This is the life of electronics. This is what happens. Things don't work and you have to find it and fix it. It's the life of an electronics technician. So what I'm going to do with this one is remove the flux. And let's see how that works for me. Fortunately it's only on the resistors. Should clean up nice and easily. Get that dried off. See how it behaves after it's been cleaned. Right, that's dry. So it's sitting at an output of 20 volts. And that's after washing. Interesting. Very interesting. There's a possibility that we have some alcohol underneath the IC. It's not quite cleaned up yet. I wonder what's going to be the easiest. Hot air station or hair dryer. Let's get the hot air. There's no room on the bench for this, so it's going to have to stand on the floor. Or on another desk. Kinda. This is 100 degrees C air. So if I hold it there, like so, don't burn me. See how that works out. That's the lowest I can go on this hot air is 100 degrees C. Alright. Let's cool down. Try that again. So that is busy settling down. So the lowest I can go on this hot air is 100 degrees C. Keep away out there. So what I'm going to do, grab another one of these that we've been pre-soaking. Give it a scrub, dry it off, see how that works. Like so. Close that up. Try and wick off as much of it as possible. Turn that one down. Fire up the hot air again. that dried. Like so. Let's see if I put that over there. I'll move it like that. Not really. I can bring that closer like that. But sure, the bench space here. So let's turn that one off. I was also not planning to use the hot air for the live stream. But this is real life. This is how it goes. Things go wrong and you have to deal with it. Let's see. That one should not be behaving. Oh, there we go. Seems to be settling down. Now that's going the right direction for me. Put the lens cap back on. That is looking good. Oh, we got 5 working boards so far out of 10. Let's just select live chat over here. Quiet evening here, but then I don't generally live stream, so people weren't expecting this. It was an impromptu thing today. I've upgraded that camera over there to the same as this Parrots, so that has improved the image quality a lot. Decent webcams. Going back down to Nordvolts. Okay, that one's good. Very good. things are looking up. I'm going to set that aside. Get another one out. Get our brush and start scrubbing. Start cleaning. Get everything off. Set that aside. Clean up my mess. Get the board dried off. See how we did. The hot air going so long. Right. Now you can see what I'm doing over there. Just going to hold it like that. That's 100 degrees CE, so it's hot but safe. Get the board nicely dried out. Yeah, manufacturing not for the faint of heart. It's not straightforward. There's always things that go wrong and you've got to know how to deal with it. It's like that. Put that away. That in there and fire it up. Alright, give it a moment to see how it settles down, or not. Some of them are making me work, that's for sure. I'll give that one a moment. Get something to drink. A beverage. There we go. I suspect that we still have a problem with this one, but let's give it a moment. Yeah, I'm not happy with that. Although it is dropping. The board is still hot. That's the other thing. that does cause an influence. That does have an influence as well. Although I'd have been happier to see that it not volts by now. Let's start cleaning the next one while we're waiting for that one. Wipe the brush off before dipping it again. It's still busy settling. But I think we're going to have to relook at that one and the solder joints on it. That offset, that 5 volts is basically still a problem. Where's it gone? Get this board dried off. Like so. See how the sun works out. Fortunately, I'm building this for stock. It's not like this stuff has to be delivered tomorrow. Because otherwise this would be bad. It would not be good at all. Trying to get stuff to work and you have to deliver it. Done that often enough in my life, and it's bad. It's not good at all. Yeah, I'm not happy with that board. We'll have to look at it. Let's put it over here. Okay, this one is settling down. While we wait for that one. hard to tell. Because visually it all looks good. Sports has some flux under the IC on the legs over here. Let's start cleaning. I think we need a bit more sauce. And I need to get another bottle out the cupboard soon at this rate. Luckily we have enough of that stuff. Paper towel as well. Make sure you got lots of the stuff. I'd like to see that getting closer to Nordwald's. Let's give it a moment. These instrumentation op amps are very sensitive to leakage currents. The hygiene in the manufacturing process, very important. Oh dear, got the battery running flat. I forgot to turn on the power on that laptop where I'm watching the chat. Right. Get the hot air going. Board is kind of getting in the range where I want it to be. You might just pull it out and examine it for more flux residue. nice and dry. See if we can get all the flux out. Like so. That's what we want to see. Nordvolts must be Nordvolts. Okay, I think we're beginning to understand our problem here. The hygiene is critical with the soldering of these boards. Absolutely all the flux has to be removed afterwards. Yeah, there we go. Yeah, that's where it should be. Let's have a look at this one. Yep, it's still got some flux. Let's keep cleaning. My headphones keep on interfering with things here. Paper towel. So let's start cleaning. At least the stuff does come off quite nicely. Clean it over the towel so it doesn't drip flux back into our clean alcohol. Like so. Really get in there between the pins. Get as much of it out as we can. Get the brush clean. Close that again. Clean that up. Guess I shouldn't be dabbing too much of it back onto the board. Right. Some hot air. Dry it off. Like so. Get this nice and warm. and inspect it and then plug it in and see how we're going. It's nice and warm, that's for sure. It's also nice and clean now. Got all the flux out. Oh yeah, look at that. Just want to send a message to a friend, tell him I'm live. Right. Ah, this is good. I think we got it sorted. So cleaning up of the flux afterwards. Got to get absolutely all of it out there because the stuff's conductive. Back down to 0 volts. Perfect. Back up to 50 millivolts. Go to minus 50 millivolts. Go back to 0 volts. Perfect. Okay, let's clean the next one. Get a tissue, paper towel. Got 3 left to do. At least the stuff softens up very nicely with the IPA. It comes off easily. That's a big plus. That was the issue with the other stuff. For one, I wasn't too happy with the soldering. The other problem is it was an absolute pest to clean. And battling is no fun. Absolutely no fun at all. That cleaned up. Get a fresh one. Dab it off. Cover that up. I want to remember that we are working with flammable stuff here. Now get some hot air. Get this one dried up. Get it dry. Then have a look with the magnifier and see if we got all the flux from underneath the ICs. These are Oppo 7s that we're using on this. That instrumentation op amps. Alright, that's starting to warm up quite nicely. Let's have a look. I still have to clean this one a little bit. Okay, let's take that one out. Add it to the pile of working ones. I did see on this one that the chip has still got some flux on the pins. What I'm doing is just pushing down on the resistors and the ICs to see if we've got any bad solder connections. No, we don't. Okay, let's clean it again. Because there's still got flux over here on this one. Get in there and try and get it all out. We've been going for almost 2 hours. We're having fun. I haven't seen anybody in chat yet, so I don't know who's watching. Let me try and refresh this page. Got a laptop over there so that I can see the chat. But people are not used to seeing me stream, so is it possible that I'm talking to myself? Let's press play. But then again, the stream will be available for watching later. I don't think anybody's watched it yet. Nope. That's okay. This will be available for watching at your leisure. Right, let's see if we got this one cleaned up. Need a hottie. See if we can get this working. We're down to the last 3. So we're making progress with this. Everybody's learning something. Everybody is just enjoying a chill stream here. Tomorrow it's back to work. This is the Sunday evening here in South Africa. So it's the end of the weekend for us. And tomorrow I get to go to work and occupy a chair again. In my work, there's a repair administrator. So all the repairs that come in, I do the paperwork. I book it in. I do all the filing. Once the assessment has been done, I do the costing, I do the quoting. I also do all the photography of the product as it comes in and as it goes out. I'll make sure that all the labeling gets done. Generate the QR code. And because we put a QR code on it, which I custom generate. So that is my job during the week. Let's see what we've done wrong here. Whatever the problem is, it's not obvious. Let's close that up. Let's plug it in one more time. That's not really what I'm hoping to see. And yeah, let's keep moving. Let's get another one and start cleaning it. What's going on here? This box is acting stupid. This piece of plastic is making a nuisance of itself, which displeases me. So good, almost out. Let me go get some more. Be right back. We have another box. There's no shortage of this stuff around here. I'm not too sure if that board is working the way it should. It should go to Nordwalds and sit there. See what we can do about getting the flux out here. See if we can get these working. I'm probably going to call it quits at about 9 o'clock so that I can make myself some food and have supper, and also so I don't bore you guys too much, because this isn't really all this interesting. Whilst still at school I used to do this for pocket money, assembling boards for my dad, which I'm still doing 40 years later for pocket money. Nothing's changed. Still enjoying it, still learning. This is what helps buy electronics for projects for YouTube stuff, the stuff that you see me tinkering with, faffing around with. Alright. Close that up. Get a bit of hot air going. You guys need to let me know if you would like a Sunday evening stream where we just sit and talk and maybe do some stuff together. We get to know one another a bit. Maybe do projects, that sort of stuff. You don't have to just sit me and watch me fooling around with this stuff. We could make it more interesting, that's for sure. You want to just come in and hang out in the chat and talk, I'll listen to you. That's also okay. It can be a purely social event. A lot of people want that, and you're welcome to do that here. That would not be a problem. Let's see how we get on. We're almost there with this. I was certainly not expecting to have this problem. Been making these things for the last year, and there's an odd connection that I haven't soldered. But this issue with this new flux of mine being conductive, it puts a whole different spin on this manufacturing process. I'm going to have to come back to this board. It's not happy. This one's not either. Bugger. No, I just carry on, find it and fix it. If the component values are right, components are in the right orientation, and everything's soldered, they should just work. Why is this not live? Should actually check that I've still got enough internet. Hello. Yeah, there's plenty. Plenty. No, he's lost 3 boards, so I'm going to have to check all the solder joints. Something's up. And I will retest all of these as well. Stream's so boring, even the sex bots haven't joined in. Even the spammers don't want to join in. Oh dear. Oh no. What have we done? It takes a while for this whole thing to sort of grow and evolve if one's live streaming. It's not, if one doesn't normally live stream, people are not expecting it. I didn't want people that I was going to live stream, so I didn't know if I was going to live stream. An impromptu thing. So it's not like we had a chance to gather an audience around here. Get this all sorted out. Not at the end of the world. The stream will stay up and one can rewatch it, and if you just want to have it in the background and listen to me talking for some company later on, that's also fine. Many people do that. Right. Let's get in there. Now that should be settling down. What I'm gonna do, for popping this one in, let's just inspect it. Check that I got all the flux out. Yep. Let's see how this goes. So I think what we got here is an issue with the solder joint. Just let the board cool down, because that does affect things, but it should already be much closer to 0 volts. It shouldn't be slowly drifting down like that. So what I'm gonna do, pop that in there. And let's reflow it. Let's get that clamp away from the where I'm going to be working. I'm only reflowing the resistors because they're the villains in this case. the ICs of the legs coming out the side, and that easy to sort out. Oh, the resistors, it's another story. Because the solder has to go underneath them. Okay, I think that's flowed. That aside, clean it, retest. And remember to look over at that PC. Check if any visitors have showed up. Okay. Dry it off. Hot, 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 hot. This is 100 degrees CA. It's not dangerous, but it's hot. I think we're getting there. Let's see how that worked out. Yeah, that's certainly more like it. Let's reflow this one. that's more like it. We are getting there. I'm forgetting to talk. Almost done here. I want this iron really cranked up heat wise. How's this one? That's full scale, one way. Let's check it in the other direction. Yep. That is good. Let's clean this board. Actually, I think there's a chance that we might be where we need to be with this board. So let's clean it. Retest. Then we got one more to fix. Then that's gonna be it. Alrighty. Let's get that dried off. Some good hottie. See how we did with this one. And the reason we did this is because the op amp that this replaces has become long lead time, and they're like a few £100 each. It's become ridiculous. And that really makes a difference to the cost of the product. No, it's like $500 or something like that extra if we buy the op amp that we used to use. You know, you can't just pass that on to the customer, but it's not good to absorb that cost either. Let's see how we did here. Board's still nice and warm. Let's try reflowing this one. Then I think we're going to call it a day. Look at start. Go look at getting some food in the oven. And a bit of quiet time before tomorrow time. Just reflowing these resistors. Make sure they properly soldered. Turn that iron off. Because I think I'm going to call it a day after this one. Go get some food. And it's getting towards 9 o'clock. It's getting late. Certainly a different stream. I'm not planning to show you how one battles to make things work, but that's life. And that is how it pans out. When somebody makes something look easy, it's because they know what to do, know what not to do. They've been through all this pain. Let this last one dry it off. I didn't look under the chips. There might still be some flux there. That could be the problem with that other one as well. That is what happened. Because it's not getting quite down to the voltage I want it to be. A bit of an offset there, which we don't want. So we'll get in there. Alright, that's dry. Turn that on off. Oh yeah. That's where I like it. Perfect. That and more like it. So look, see. Now what is going on here? Certainly got it clean. That one can go over there. This board's got a bit of an offset. It could be a resistor value. But it's not zeroing. Not happy with that. That would not be a pass. But for now, put our flux away. And then off the Q-tip. Discard the Q-tip. Get that lid on. And I think we're going to call it a day there. Right, thanks for being here. Thanks for watching this after the fact. If you're here watching it non-live. And right, have an awesome day further. Take care, ladies and gentlemen. Now I'm out of here. Right, see you next time. Cheers.